Okay, all right. So that's like just to give you, like setting a base for all of us to have a good and smooth sessions. Okay, so before we get started, right? I mean, I give you a high-level introduction. See, people would have heard about this analytics field, data science, and all these terminologies, right? There are different terminologies you will hear, but just to get a hang of what this analytics is all about, and also how is it helping in real life? Why is that this has become such a big buzzword, and how is it really? Is it really practically being used, or is it just a buzzword? Okay, so I'll talk a few of those things as well. So this is basically to get you a introduction to the kind of content and kind of topics that we'll be working on. Okay, so first question, even before I start discussion, why did you, I mean, what did you read about this analytics, and what did you understand? Like, what is your idea about analytics? You can put your this thing in the chat. Okay, what is your idea about analytics? Many of you have already worked in analytics, and few of you are new. But since you have joined this course, probably you would have done some background reading about everything. So, what is analytics? Getting future insights by past data. Very good. That's a good point, actually. Analyze data and create different data sets. Okay, good. Analyzing data and extract useful information out of it. Very good. Good. Forecast customer expectation and shape a product accordingly. Very true. Okay. Solving business problems using data. Good. Getting insights and making informed decisions. Very true. Studying past data, making the best use of and best use of that for improvement. Solving a problem with data available. Okay, so the way I'm looking at the answers, right, it makes me think that we all understand that analytics is all about data, right? It's all about data, right? So without data, we don't exist. Okay, especially this field doesn't exist if data is not there. And given in the current situation, right, of how we are flooded with data, okay, there is a lot of potential for analytics on that. Literally, you're sitting on tons and tons of data. Okay, but just imagine, can a human go in each of these lines of data sets and try to understand? That's a, I mean, time consuming. And as a human, I don't think we have that much of patience to sit and go through each data set, right? That is where analytics comes into picture, right? You make use of your uh, capabilities of analyzing this data, automatically come up with insights out of this data, and that is where analytics comes into picture. Understanding the data and getting insights from it, information out of it. It's just not data dump, it is getting information out of it. So you guys got it right actually in this case. So there is it's all about data. Okay, and analytics, just like few of them put some definitions for it. So the way they have said is this: the extensive use of data, statistical and quantitative analysis, explanatory and predictive models, and fact-based management to drive decisions and actions. It's too technical, don't worry. It's more of, what you have to understand is, you have data, you analyze the data, you get insights out of it. Okay, this is where, right, analytics brings in the, what you say, the kind of help which it can give us. Okay, because just taking a data and analyzing it sometimes gets you to one level of information, but there are a lot of advanced stuff that you can do which can help you generate a lot of more other insights out of this data. Okay, and that is where we will be discussing a lot of those advanced stuff. See, if I think of it right now, we all can generate insights from any data set, right? Just imagine taking a mean of a particular column is an insight, right? If I take the average of a particular column called age, that is an insight for me, right? The average age of the population is, let's say, 30 years or 27 years. So that's an insight. That means my population is a young population, right? Working class population. So that gives you a better idea, right? That's an insight you have generated from one column. Like this, there are a lot of other advanced things which you can generate. So What is analytics? So, I can tell you one thing. Probably there is a lot of other experienced people as well, but from my experience, I can tell you when I started off, let's say in this domain, right? Analytics was a very small, let's say not a major player. Okay, it was a small domain work related work which companies used to have. Okay, it was not a big buzzword, and the kind of work we used to do was like a lot of uh, detailed analysis and all. But over this past few years, right, the technology has improved so much. Literally in front of me, I can see the kind of work I used to do earlier to kind of work I do now. Okay, and frankly, I'm telling you, you guys are in the right phase of this field, because the trouble which would have been there earlier, right, it has reduced a lot, right? Because earlier you used to literally dig through the data to get some insights, generate variables out of it, and the kind of algorithms also, right, were very few. Okay, but now the research is so fast. Okay, there's so much of research happening, and people are I'm telling you, every 6 months you get outdated. Okay, every 6 months, like, there's something new that comes up, and you'll go outdated. Okay, so you need to keep reading these new research which comes up, and then you need to keep yourself updated with that, because the field is changing so fast. Okay, just imagine, the Google search engine, which you work on a one kind of a algorithm which was there earlier, but now they have improved that algorithm further, which makes it like, literally, how many of us would type the whole sentence in Google? Literally, we just say what is, and you get the question that you want, right? So it's already there available. How is that Google done it? Okay, that is because they have done a lot of research. They have come up with new algorithms which have improved the results that are coming up, right? So that's the kind of pace at which things are moving. Okay, and now, let's say earlier, right, this field, um see, I keep telling, right, earlier and now, because I see the clear difference. Okay, so I'm just telling you all the kind of how it was at one point and now how it is. Earlier, it was more like, I we used to only deal with data. Okay, only data. So I used to not bother about the technology side. I was more on the data side. Okay, analyze data, give it to the guy who is from the technology side. He'll implement it for me to make it productionized. Okay, now literally it is like, I have to look at the data, I have to build the technology, I have to look after the technology, I have to do the deployment, I have to give it to the end customer. Literally one man show it is. Okay, literally one man show. So it's like, what happens is, over a period of time, now it has become that the person who is dealing with this kind of work is supposed to know a lot of things. It's not just your work related. Okay, so what happens because of that, you are supposed to have a good idea about the technology. Okay, you need to have good domain knowledge, and you need to have a good knowledge of stats and maths. Okay, but again, now it's not necessary that, I know we all come from different backgrounds, right? So it is not necessary that you need to have a detailed knowledge of statistics, mathematics, computer, or that domain. Even if you take a look at my work also, right, I have never stayed in a particular domain, because my interest has been to look at different data sets. But there are a lot of people who stay into one domain. They stick to a particular domain, they become a subject matter expert, or let's say they become an expert for in data science for that particular domain. It's completely up to us of how we decide how we want to take our future career. Okay, so it's there is a pros and cons for both of this. You staying into one domain and picking up things, or you picking up different data sets. Okay, you working in different domains. So I have dealt with media, as I was telling, right? I work with media data set, I worked with insurance data, I worked with pharma data, I worked with um, retail data, I worked with real estate data. So it's like you get to see different kinds of information that you get. Okay, and but yes, I'm not a domain expert, because it's one of, like, it's each individual's preference also. Coming from a domain like stats, my goal should be to help solve a problem using the kind of algorithms, the techniques, the solutions that I know. Domain is no barrier for me. Okay, so domain should never be a barrier for you, because every domain you get into, you pick up the domain's knowledge. You may not be an expert, that is not required. Okay, that is not required that you be a domain expert, but you should get a hang of the data set, what the data is, what does that variable mean. All these things you need to understand. Okay, but there are people who are experts. That is another advantage. Having a domain knowledge is a added advantage, because when the guy is building that particular, whatever we call that as an equation, right, he has a clear cut idea of what that variable should look like. Whereas sometimes we may require someone to help us out on that, telling that, okay, this variable seems to behave like this, is that a correct or not. That you require someone's help. But right, so there is a pros and cons for both the kind of choice that you make. Okay, and so the whole point over here is, you need to know a bit, you need to know technology, you need to know the stats and maths, and you need to have a domain knowledge to solve the problems of a particular industry. Okay, so that's the ideal case for each individual. So he should have this kind of idea about each of these concepts. So, and I think overall we all understand, right? It's just not the data. You take the data and generate a information out of it, finding the patterns inside the data. And remember one thing, I mean, I have faced this challenge, okay, that people think that AI is magic. Okay, like the common term, it's AI, right? It should be able to do it. That's not true. Okay, we need to realize that end of the day, it's all about data. If your data is garbage, the output is going to be garbage, right? If your data is not having any information or pattern in it, it's everything random. AI also can't do anything. What you can do is, you can take AI to see and to see if it can generate some insight. If the data is garbage, what insight will it give? So there are certain scenarios where you need to be upfront and say that, your data is junk. Okay, we can't use it for any purpose. So your data should have some pattern, and the data will be able to generate the insights for us. So why get into all these things is analytics, right? The whole idea of analytics is now how fast you can reach to your customers. Every day is like a competition among the business, right? Who is reaching out to their customer better? Who is able to keep their customer happy? So this becomes like a competition, right? And now if you want to stay on top of it, you need to be a little bit advanced, right? You need to do stuff which can help you capture that kind of information. So that is where analytics helps you. It helps you improve your business. Also it tries to help you understand your customer. Okay, it helps you understand your customer and do what your customer wants, not what the company wants. Okay, there was a point where customers took what the business gave. Okay, it was like, I have, let's say, one product, and I'm selling that. Customer has no choice, he buys that, even though it may not be to his 100% satisfaction, but he has no choice, he buys that. Now the situation is different. You notice how much of customization is available to the customer. It is not what you produce, now it is like what customer wants. Based on what the customer wants, the business is trying to adjust themselves and try to generate and give them to make their customer happy. Okay, so that's where right now the business has to be very dynamic in understanding the customer needs and try to prepare themselves accordingly. And I think this is the last point, right? It's more to say, uh, earlier it was like, let's say, based on people's experience, that you used to come up with some solutions. Like, let's say there will be someone who has a very good knowledge, he has been working in a particular industry, so he would say, okay, I have a strong feeling that the market is going to go down. Okay, that's like personal opinion. Okay, of that person's personal opinion it is. There is nothing to back it. It's just that from his past experience, he has seen that it happens like this. So he tells that it's like, his gut feeling is that, it is going to happen. But now, no, not everyone believes in that, right? Not everyone will believe what the person says. So what you need to do is move from this kind of, guesstimates, they say. Okay, guesstimates means, from your feeling you make a guess. So you need to move from these guesstimates to something which is more data oriented. Data oriented means you come with a backing for your insight, saying that data says this is what is going to happen. And that is where you have a strong backing of your data to tell that this is going to happen. Okay. And there also, again, it's not 100% because we are not some magicians who can find out what is going to happen in future and tell that no, this is going to happen. We are being prepared ourselves for the future. That's it. Okay. We are preparing ourselves for the future so that we can face it not as a sudden unexpected challenge, but at least like we are prepared 80% of the time or 90% of the time. That's the kind of way how analytics is helping. Okay, so I think as I mentioned over the conversation that we are having, right? Why analytics? Okay, why is analytics used? As I told you, so decision making is now fact and performance based. It's not something you guess or you have a gut feeling that it will happen. It's not. It's no one is going to buy that. Okay. Second is intuition is out, metrics are in. So it's the point, right? You don't want someone telling from their experience it is going to happen. You want some numbers, some KPIs in front of you to tell that it is happening or it is going to happen. That is what is important. Next thing is competition. Why do you think people want to go into data science, artificial intelligence, NLP, all these things? Why do they want to do it? Only reason is there is intense competition. Just imagine there are so many big players in the market, but there are now small startups which are coming up with brilliant ideas. And they are literally, causing a change in the environment of how things used to work. Okay. For example, I'll take a simple example. You know, claims. Okay, in insurance, right? Insurance claims. Earlier, just imagine a scenario. You hit your car. You have to call a customer care. That customer care will take your complaint. He will send one person to evaluate your car damage. Then the process will start of your payment. Let's say it takes at least 1 month to get your amount. Okay. That was the kind of scenario. You know now how fast it is? Literally, the guy can just click a picture in his mobile and it can estimate how much damage the car can have. That's artificial intelligence. Okay, so you just have an app, you just click the car from all the four sides, automatically it will calculate how much is the damage that is there for that car. Okay, so that's the kind of thing. Just imagine now how satisfied as a customer you would be. Won't I move out from the previous company to this company who is doing it so quick? Okay, I don't want that headache, right, to wait for 1 month. So what is happening? There is intense competition over here now. These startups are coming up with these kind of challenges. So people have to start fighting for that, right? So people want analytics to help them do that. So what is happening now? There's intense competition, short time to market, and demanding customers, right? So that's end of the day. That is what is happening. Everyone is trying to compete and become better and better, and that is where AI is helping them do it. Okay. The next important point is making each and every dollar count and increase return on investment. End of the day, how much ever technical you are, how much ever technology oriented person you are, end of the day, what matters is ROI, right? A business person or a management team doesn't bother you are using R, Python, artificial intelligence. It doesn't matter to them, right? It is more like I've invested $1. How much are you giving me on top of that $1? That is what matters to them. So how do we make sure that every dollar that you are investing is accounted for and also shows, as I told, not guesstimates, also shows how much is the exact return I'm getting on top of it. Let me take a good example here. Just imagine earlier, right, in media domain. Earlier, people used to say that like these TRP ratings and all are there, right? It's just because of this TRP ratings they're able to say how good is a show or how much attraction a show has. It's but and again another thing is, let's say on radio, you advertise on radio or you put a board in front of a like anywhere you put a big board. how do you know how many people came to your product because of that particular board, or because of your marketing on radio, or because of your marketing in newspaper? How many people came? It is a very rough estimate. It's a very rough estimate. Like you say, like 1 crore people have got my paper, I'll assume that 30% of people have come because of that. It's a very rough estimate. Okay, so this is like something we could not, track it. But now just imagine how things are. On Google, you go and search, you go into one page, you check out something there, you go into another page, you check out something there, and you click one link over there and you buy the product. Okay, so what happens? Literally, you are tracked from where to where you reached. Okay, so I know the path from which point to which point you have moved, and I can say that, okay, instead of me investing into a particular place, I would rather invest here because I'm seeing more people coming to this and coming to my page or coming to buy my product. So I don't want to waste my money too much into a particular expense. I would rather put it over here. Okay, so that's the kind of tracking you have. Like every dollar I spend, I know where that dollar is coming back for me. Okay, so that's the kind of tracking you're able to do. And I think, given in the current situation, the whole world is moving online. So it's not that difficult, I guess, to keep track of what is being done, right? So that's one way of how you can track your investment, return on investment. And finally, taking real-time decisions. Everything that happens is in a real-time basis now. So let me take an example of a real estate. Okay, in real estate, I had worked on a problem statement where we were predicting in real time what is the price of a property in a particular locality. It's a real time. Like now also, if you go in any of the property portals, right, they'll show average price of this locality is 3,300 per square feet, 6,000 per square feet. You have, right? This was a live tracking. Okay, like literally anyone posts anything, there's a up or down of the price. Is the market going upward in a day-to-day basis or downward? So that was the kind of a problem. So this was a real time. Okay, so all these things, right, that we are discussing is what has made analytics, AI, all these things very, important for any particular industry to start using it. And that is why people have started accepting it. They want to do all these things. Okay, because they are sitting on huge amount of data, but still they are not able to extract the insights out of it. So that is where this AI and analytics is everything helping them. All right, guys, so I have been talking a lot. Now it's time for you all to talk. So okay, so here you have an image in front of you. Okay, so what I want you all to do is, I mean, if you want to talk also, I can unmute you, but if you want, you can put it in the chat. What I want you to do is, from your knowledge of what you think about analytics is, I want you guys to connect your thoughts to each one of this image. Okay, so we'll go one image by image and we'll try to connect to the original fact of how we connect this to analytics. Okay, so let's take this first image here. You see some things like, some eggs are there. There's a cocoa powder, there are chocolate chips, sugar, salt, milk, and all those things. So this is, okay, I already got an answer. Great. This top is raw data. Okay, so everyone feels this is raw data, or it is just some junk kept over there which is not required? Okay, good. So it's basically the raw data. Okay, so these are some ingredients which you have taken. You want to do something, your end goal is known, so you have got the raw data. Very good, you connected this. Okay, now how do you connect it to this one? Transformation and creation of model. Okay, good, well put. What else? Others, what are your thoughts on this image? Finished data. Very good. Processing. Okay, good. So what we are trying to say is, this one, exactly, it's a processed data, or it's a transformation of this raw data to some particular shape. Okay, so this one is something that you have taken this raw data or raw materials and made something, some processed output out of it. What do you think is this? Visualization. Okay, that's good. Finishing. Okay, Okay, so this is like the finished product, final result, right? It's the finished product or the final product or the end result. Okay, so this is what your end result is. But one thing, if I ask you, why do you want to give this, why not give this? This is also, it's almost the same thing, right? How does it differ? It's just a cake, right? Finally it's also a cake, this is also a cake. How does it differ? Why do you want to give this? Presentation. Okay, so I think that is most important part, right? Detailed and the presentation part. If I go to a, let's, I mean, it's in a very layman terms, right? Yeah, exactly, visual representation, explaining it to a layman language to management. Exactly, that is what happens, right? If I go to a cake shop and I look at these two cakes, naturally I'll get tempted to buy this cake, right? This looks, it's good. End of the day, this is also a cake and this is also a cake, but what looks more attractive? This one looks more attractive. So what is the end goal? Any problem statement that you solve, however technical it is, okay, you shouldn't give it as a technical output. You need to wrap it in such a way that it is presented to the end person in a very attractive, especially, right, you're going to give it to a business team who doesn't understand what you have done. So you don't give them your technology and technical aspects to them. You give them an end output which is easy for the business team to use. They just have to, you know, I don't want to bake this cake and I don't want to do everything. What I need to do is I just need to put my spoon in this cake and eat it. Right? That's how it should be for a end customer. I don't want to take the trouble of making that whole cake. And I don't want to know what you have put inside it also. For me, it is eating. So if you connect it back to our concept, it's basically presenting it in a very attractive way, simple way, and you have it as good as that. What is this? The last image. Testing the product. Okay. Sample. Okay. Anything else? Anything else you can connect this to? Usable. Okay, good. Consuming. Okay, that's good. So, basically, if you're baking a cake, delivering the client to use it, yes, that's true. Actually, that's actually a very good point, right? Delivering to the client. Okay, leftover that can be part of raw data. Okay, you can say that way also, but just think of it this, right? You are baking a cake. Why are you baking a cake? And why are you trying to make it attractive? That means you're trying to sell it to someone, right? That means there is someone who has to buy it, right? That means someone there is who is to buy it, who is interested in it. So that end consumer, whoever it is, should be there. Like, you should give it in something what the end consumer wants, not what you want. So that is why the end image is telling you build or you do something what your end consumer wants to consume, not what you think or what you want to do. So the end goal of what your problem statement should be is, what does my customer want? What does my consumer want? According to that, I take all the raw materials, I bake the cake, I make it attractive so that he can consume. Okay, so that's the kind of the thought process. This is not some step 1, step 2, step 3, step 4. It is not that. The thought is, you need to have the end picture in your mind and walk towards that picture with all the things that you have in your hand. You just take everything, start developing things and go towards that end consumer, whatever he wants. Okay, so that's about how to think of how you can use analytics and how you can make it more something that the consumer wants. Okay, so as I was mentioning, right, the thing is nowadays it's more of competition, right? So how earlier the decisions were taken was they were all reactive decision making. Sorry, that means there is something that happens. I mean, there is something that steps are taken only if something happens, right? So my sales go down, then I realize, oh, my sale is going down. Why is it happening? I go and check for that. So that's something which is happening after the issue has happened. Okay, so now, like for example, which region has the problem? Which region has the problem means there is some problem already over there. I'm realizing it now and I'm trying to correct it. What if I could do that beforehand, before it reaches to a point where it becomes a problem? Okay, so that is your proactive decision making. Proactive decision making means before some challenge comes up, you tend to come beforehand and try to resolve it. You don't get to the part where it becomes a problem and then you start solving it. Instead, you try to solve it before it becomes a problem. So that is where you this proactive decision making helps, and that is where analytics has the capability to help you identify such problems and beforehand tell you what could be the challenges and how you can try to resolve it. Okay, so that's a proactive decision making. So if you think of it, what do you understand from this image? First of all, what does it look like for you all? What does this image look like? Car mirror. Very good, right? Okay, Prashant, you asked why the reactive points are in red. Okay, it's mainly to tell you that you are basically trying to solve a problem after something has become a problem. And why the proactive are in green is you're trying to reach out to a problem before it becomes a problem. That's why. Okay, so that's the part of it. So this, as you guys told, is the middle mirror of your car. So now if you want to connect this to what we are talking about, what do you think of it? No one behind you. Okay, you are foreseeing an issue using analytics. Exactly. Okay, so what do you see in a rear view mirror? You're basically trying to see what's behind you, your past, right? Just think, I mean, you try to connect it to what we are talking about in this topic, right? So you're looking at your past, and based on that you're predicting what will be your future. Okay, so you will know that in my past, let's say it has been a challenge, I can predict, okay, in front of me there will be something like this in future, I need to be careful. So that is the whole purpose of analytics. Okay, looking at your past data and trying to come up with something which can, before it becomes a big issue, you try to resolve it. Okay, that is where your predictive analytics. Okay, so there are a lot of things, right? There is analytics, predictive analytics, prescriptive analytics, a lot of things are there. Okay, predictive analytics is basically about predicting what can happen if the situation continues like this. What can happen, what is the risk that I can come across? Correct. So that is what your predictive analytics is all about. So BI is business intelligence, right? So business intelligence is what gives you information of what has happened. Okay, so till now, let's say so far most of the companies have been doing business intelligence. Business intelligence means you are basically looking at what has happened in your data, past data, and trying to find out that there is a problem here, there is a problem there. But you are not able to, what is it, it's not like real time. It's like something has happened and you are trying to resolve it now. But predictive analytics is, it is going to look at the past and tell you, okay, there is something going to be problem in future here, so you better resolve it now. That's the advantage you get with predictive analytics. Okay, so as I mentioned to you, right, industries that are accepting analytics has been like increasing over the years. The adoption has been like really fast. Okay, and they have realized, every domain has realized that it is going to help them. And this is like an investment. Okay, analytics, data science, or everything is an investment which has a, at a longer period of time you start seeing the benefits. It's not like immediate reactions that you will start seeing, because these things, right, of whatever you implement, you will start seeing the impact of it over a period of time. And that is why people are investing in it and waiting, so that they can start seeing it, the returns on it. And people believe, and it's actually a fact also, that investment into data science and analytics is going to help them. And that is a fact, it has helped them a lot, literally a lot. Okay, and these are the, like, just a few of the domains, okay, which they have analytics is being used heavily. Banking is one of the major domain which uses analytics. They have been using it for many years. Okay, but now they have moved into more advanced stuff, let's say. Main reason being there's a lot of rules and regulations on banking, right? So you cannot do anything easily over there. You cannot change your things because everything, like, let's say you're building a model is nothing but an equation. Okay, you'll come across this term more when we keep talking. But a model, whatever you want to introduce into a banking domain, right, it goes through a rigorous process of identifying if you are doing something wrong, or it could impact in some way, or it could cause a bias, like, just a very what do you say, like a very um, basic example. Like, if a particular um, model of yours or an equation of yours differentiates between North Indians and South Indians, or East and West, right? So that's a bad thing, right? Your model should not do such kind of things. So these kind of issues, right, just imagine if your model starts giving loans only to North Indians, or only to South Indians, or only to East or West Indians, right? Whatever it is. Okay, so it's becoming like, that your model is trying to be biased towards a particular group of people. So banking is very rigorous that way, so they don't pick up everything so fast. So, but banking, there are other parts of banking where there is a retail, right? You want to sell your credit card, or you want to sell your banking, you want to open more banking accounts. Which customers to target? Here there is no risk, right? Because it's more like reaching out to a customer. Okay, so banking is one good example. Okay, like, for example, like, one example to give you is, what if a person will pay back your loan or not? This is one model that they use. Then there is credit profiling that they do. Okay, there are a lot of models like that in banking. Media media is a very interesting field. Okay, because I think we all, day to day, we are with, we involve ourselves with media, right? So I can give you an example. Media is very interesting because um, they track a lot of things to understand how the consumer is reacting to how your investment should be. Like, in media there are a lot of models which can help you identify in which particular uh, channel you need to invest. Like, whether it should be a radio, whether it should be a TV, whether it should be a board where you need to put, or whether it should be in Google. All these things, right, they analyze and tell you should invest this much amount here, this much amount there. They tell that. IPL matches are happening, right? All the players have ads on their dresses, right? Certain ads, if you notice, they are very placed in such a way that you can notice it. Okay, like, for example, a right hand batsman will have it on his left hand, right? Because you're facing the camera from that side. Okay, so what happens, all these placement of ads and everything, right, matters a lot. So they do a lot of analytics on that also to identify which position is getting more views. Okay, another important thing is brand awareness. Brand awareness is like a very big thing. People invest a lot in brand awareness. Just imagine, something is being shown to you continuously, you tend to remember that product. Correct, you tend to remember that product. That is a brand awareness. Okay, so more you are shown, you tend to recognize that brand, you try to connect with it. Okay, so that's what happens with your brand awareness. So, and people, brands spend a lot for that kind of awareness to get, connecting themselves to the customer. Just a very let's say a quiz kind of a thing. How many brands do you think in a day you are exposed to? Can you tell? Average, how many brands do you think you are exposed to? 10. Okay, 10 to 12. Okay, any other numbers? 10 to 15. Okay, okay, good. So you know what the number is? 5,000. You are exposed to 5,000 brands every day. Okay, why? Just imagine, from the time you wake up till the time you come back to your bed, how many brands you are exposed to. The slippers you wear, the toothbrush, the toothpaste. Okay, maybe use a mouthwash. Okay, then the breakfast. Kellogg's, okay, a milk, then the car. All these are brands, right? So you are being exposed to almost on an average 5,000 brands in a day. And you tend to remember these brands because you're using them daily. I want to use my Pepsodent. I want to use my Colgate. All these are brands. So you are exposed on an average 5,000 brands in a day. Okay. So that's how it works. Okay. And each brand also, right? Even the advertisement, right? They have a concept of, um, it's called, I missed that term, lag. I think it's there's a better technical term, I can't recollect that, but you know that that lag issue, right? Which what they do is basically, if I show you an ad today, how many days do you remember that ad? That is also an analysis that they do, you know, like, should I show you every day, or should I show you once in 10 days, once in 5 days? Because what happens, I show you an ad today, that ad is like, just imagine, like, you get a shock. Okay, the current shock will be there for some time and then it becomes less, right? It's just like that. You're being exposed to a brand, and then you will be remembering it, let's say, for another 3-4 days. After that you'll forget. Okay, then again after 4 days I hit you with that brand again, then again you will remember it. Like this, if I keep doing over a period of time, right, I tend to remember the brand, right? And I don't that's what I have to spend accordingly for that, right? What if I do it daily? Is it helping me? I don't know. It's not good, right? If I do daily, that is also something too much, right? People will get irritated with the kind of brand. How many times is he showing this ad? You'll get irritated. So there is an optimal point at which you need to show an ad, optimal time, how much you must show the ad. So there is a lot of analytics that is done. Okay, where you need to show the ad, when to show the ad, all these are part of the analysis. Yeah, brand recall, exactly. So these are the kind of things. Okay, in media, this is another analytics that they do. Retail is like one open. What do you say? It's like an open market. Like, you know, you can do lot of things. There's no restriction, right, on retail side. It's like, just imagine the kind of things. For example, you go into some e-commerce portal, you look at one product, and then he shows you all relevant products. He shows you what product consumers bought together. This is not random, and it is not like a very basic version, like, you know, if one person brought this, what else he has brought. There is a lot of other analysis that is done, right? And they show you very relevant products. It's not like it's just randomly they're showing you. There's a lot of relevance in that product. So retail uses a lot of analytics on that, which are the recommender systems, right? The recommendations that they do to you, the products and all. So there's a lot of things that happen in retail. Healthcare has been um, adopting AI to a great extent, and you can see the kind of help it is doing. You know, there are so many startups and so many products that have come up. Literally, they can detect cancer in the initial phases. Okay, literally they can, you know, even many of the models that people have built are able to predict a particular problem, a particular disease better than a doctor. Okay, because naturally as humans we tend to make error, right? We may miss the minute details, but a machine doesn't tend to miss the minute details, right? So that is where, you know, it is helping a lot in the healthcare side also. Like this, if I take, right, each one of them has a lot of problem statements which can be solved. And I think there was a question on the used in NGO and manufacturing. NGO probably I may not be aware of. I'm not exposed to the side of NGO where I've taken up any problem statement. But manufacturing, yes, I can tell you. Manufacturing is another big time artificial intelligence. You know, they are accepting it. Why? Because manufacturing has lots and lots of data. Why? Because of sensors. Okay, we are now moving to industry revolution 4.0, right? Probably you guys would be aware. It's all I mean, if you go back and read, right, there has been various revolutions in the industry, right? So we are currently in the industry revolution 4.0, where it's to do automation, lot of automation, robots, everything, right? That is what they are trying to do. So what happens is, in manufacturing side, there is real time data coming in. I'll tell you an example. Okay, let's say there is a product being manufactured. That product, when it is being manufactured, you tend to identify a problem at the end of the product. The product has been manufactured and then you realize, okay, something went wrong with the gas pipe in somewhere and now the product has melted. Okay, so all the whole batch is gone. How much of money would have been wasted for that? What, why, and why this is happening? Because end of the batch you realized. What if in real time I could identify that my temperature of that gas is increasing or decreasing, and immediately I could correct it? That is where, the adoption in manufacturing is coming, where sensors data is being used in real time basis, where the temperature of a particular machine is being continuously monitored. Whenever it notices that something dip is happening, automatically there is a trigger which is going, which tells that the temperature is going. Either there is a human intervention or there is a machine intervention which automatically corrects it back. Okay, so that's how in manufacturing it is being used. In manufacturing it is also being used in various ways, like to identify the quality of products, to improve the speed of the product manufacturing. So there is like n number of problem statements that you can come up with in each of this. Human resource, hr HR side, how much of models have been built on the HR side, companies working on this to improve the uh, experience of recruitment. Now literally there are so many models where literally you pass the entire resume of a candidate and it can tell you how much chance is there that this candidate will get selected. What happens over here now? It's like, uh, rather than spending your whole time in assessing 200 candidates, you will assess the top 10 candidates and maybe you may end up with those top 10, one guy or two guys. See, again, it's not like, from the top 10 candidates you will get definitely. It is not like that. It is just that it is reducing your effort. Rather than going through the 200, you go to the first top 10. You don't find, go to the next top 10, like that. Okay, so that's how it is being done in human resource, identifying potential candidates. So yeah, I mean, these are a few examples that I have been taking. There are a lot of other things, right, happening in each of the domains. Insurance, it is useful for identifying fraudulent claims. Fraudulent claims, because uh, people claim fraud. I mean, fraudulent claims they do, right? So identifying them was being done manual earlier. Just imagine a scenario where there is a third party and every claim that you give to them, you're paying $1. Okay, for processing the claim to identify whether it's a fraud or not, you're doing it through a third party and you pay $1. You give 500 such claims, so $500 you're paying them. But with analytics or with artificial intelligence, you are able to identify, let's say out of those 500 which you gave to that guy, he comes back and tells these are the 10 fraudulent claims. But how much you have spent? 500 rupees to identify those 10. What if I could identify just, let's say, 30 out of those 200, 500? My model will identify only 30 out of those 500. What I do now, I give only this 30 to that team which identifies fraud. Out of that 30, now they give me 10 back. So what is my return on investment? Right? So there I spent 500 and here I'm spending 30. Right? There I paid $1 per claim, right? So I spent $500 to identify 10. Here I'm paying $30 to identify 10. Definitely this is a profit for me. Okay, so that's how in claim and insurance claims also it is useful. Another example which I told you, right? Quick resolution of your claim settlement. Just click a photo, you get the price of the car damage. That's the kind of process that is happening. Okay, so any questions, guys, so far on anything that we discussed? Am I going too fast or the pace is good enough? Okay, good. Okay, guys. So I think before we get into the next slide, so I am assuming you guys would have done some reading through all these analytics and all, right? So what kind of tools have you come across in these things when you were doing the search? The kind of tools and like kind of technology that is used in analytics. R, Python, Power BI, Tableau, R, Tableau, Python, SQL, Tableau, Access, okay, R, okay, Tableau, Python, very good, okay. Okay, so idea. Okay, idea. I have never heard about this idea. Okay, something new for me actually. SQL, BI, Tableau. Okay, SAS. Oh, very good. Okay, someone remembers SAS also. That's good. Okay, so that's good. Pretty much, like a lot of tools that you have told. Oh, idea is used for with e-audit. Oh, okay, okay, okay. Yeah, so I think Prashant, probably it's like I don't know. I mean, I've not come across this. So I'm assuming that it is something. Is it open source? Ah, okay. Yeah, that's what. It's an internal tool. All right. All right. Okay. So see, whatever the tools all are mentioned, right? Many of them are something which is commonly used. Some things could be where, like, which are like internal for some companies. Okay. Okay. Okay, so some tools, right? They could be very specific to your company. Okay, so that could also be something. That's why people may not be aware of. So the main things, IBM Cognos, very good. So that's also another one. Okay, so a few, right? To name a few of the tools, right? This is not a complete list. There could be many more. Okay, it's not like a complete list over here, but R, SAS, Tableau, many of these names that you see in front of you are already what you have mentioned. So that is what you have come across, right? And R is one of the best tools that I have used. Okay, I still love using R, but I use also use Python a lot. Power BI, yes, Power BI is another visualization tool which you can use by Microsoft, right? It is. So Power BI, Tableau are all visualization tools. Generally, after you build your models and whatever you do, you want to show good visualization. These two, Power BI and Tableau, are commonly used. Even there is another one, ClickSense, ClickView, I think it's like ClickView. Yeah, so all these tools are good. Okay, so our SAS, SPSS, SPSS was there for a very long time. It used to be used a lot. Now I don't see much SPSS being used. But still, there are a lot of other companies which do tend to use. Then StatSoft, Statistica, then all these Excel, basic. Our Excel is also a good tool actually. So these. Sorry. So these tools are basically helping you to implement the analytical techniques and analysis work, and all these tools help you do that, right? So how do we start using these tools, right? See, many of the tools that you see in front of you are licensed versions, and some of them are open source. People who are not familiar with open source is something which is free, right? So free means everything is free, so you can literally use it for any purpose. You can download that tool for free. Yeah, you can do whatever coding or build any tool application you want, and you can sell it to someone else also. Again, there are a lot of licenses and all, so I mean, even open source has few different licenses, so you have to keep that in mind. SAS, which you see, is again a licensed version of tool. It's a licensed tool. It is used for analytics work, and SAS is dominant in banking, pharma, all these kind of domains, right? They have all SAS being used. SAS is like very dominant, and it has a good market share also still. But yeah, because of this open source, a lot of its market share has taken a hit. It's coming down a little bit. SPSS also, SPSS also is like it is a point and click kind of a tool for your analysis, whereas R, Python, and all these things are like you have to write a code for things. Dhruv, you say SAS is too much costly. Yes, that I agree. See, SAS is something that it's costly. It's enterprise version, right? So it will be a little costly. But again, it has its own pros and cons, right? For example, why do pharma or banking um, why is banking using, like, let's say banking or pharma using SAS? Because they can keep someone liable if something goes wrong, right? And that is why, like, licensed tools, they make sure that whatever output is coming out is well tested. But whereas open source, right, no one is going to take responsibility. If something goes wrong, it's your headache. No one is going to take responsibility for that, right? Because it is an open source community. Someone is just writing He's just giving you, he's not guaranteeing you anything. We just go with the assumption that everything is correct. That's it. Okay, it's like that. So everything has its own pros and cons. Vineet, you're saying we can't commercialize tool build with open source technologies. Huh. So there are things for that, right? As I mentioned, there are different licenses again. So in open source also, you can build tools and use it for commercial purpose. But if anyone asks you to give the source code, you have to give it. Okay, that's the basic thing in open source licensing. Okay, so if your client asks you to give the source code, you have to give him, because it's an open source. You are not supposed to hide yours. But you use an open source and build something which is more on top of it, let's say another layer on top of it, which is your own IP. That is something you can hide. You don't have to give that. But whatever is the source code, you may have to give it. Okay, so that's how it works. And actually the whole idea of open source is that people should be able to grow, right? So you cannot hide it. So that is why it's one of the license. So if someone sues you, right, saying that he's not giving me the open code, he will lose. I mean, the opposite party should give it to him. They will not be able to hide it. So that's how open source works. But the advantage, biggest advantage of open source is it is like extremely fast growing community. Because so, see, just imagine a licensed tool to come up with something new, right? They take 2 to 3 years. They have to take the research paper, they'll implement it, they will test it, then they will start giving it. It'll take a long time. Okay, whereas open source, the guy who has, let's say the research paper guy who has done that research, right, he will write a package and give it to you. So you can directly start using it. He'll give it to you direct, free, open. You can use it. So that's why, right, the adoption of open source has become very fast. And another thing, naturally, it's free, right? We all like something which is free, right? So that's why it's more people are adopting it also. Okay, so now what businesses consider before they choose a particular tool, right? So if you notice, as I told you, some companies use SAS, some companies use R, some companies Python, ClickView, Statistica, SPSS. Everyone has their own choice of tools and technology. Now there are many factors with which a company can go with a particular tool. One could be the cost, right? A company doesn't want to invest too much money into a particular software, then they will try to go for open source, right? But if there is something which is very rigorous, some domain which is very strict, a lot of regulations, then they have to be very careful. So that is where they can't look at the cost of the tool, but they have to go with a proper tool. So they won't bother about the cost. Compliance, is it compliant to all the kind of norms and regulations? That is what also you need to look at. Support, open source, although the communities of open source are really great, support is not mandatory for them. Okay, like for example, if you take a licensed version, he will have packages for you to give support. If anything goes wrong, he'll sit with you and solve that issue. But for your open source code, no one will come and help you. It is your headache, you have to solve it. But biggest advantage is the community is so huge that literally whatever problem is there, it's already solved. I'm telling you frankly, so far I have never come across a challenge which is not resolved. Any error that comes, just take it, put it in Google, you will get a solution for that. Okay, so that's how the support in open source works. Ease of use. There have been so many tools that have come in the market and gone because they are not easy to use, or their adoption is not easy. It has its own problems. It cannot be integrated into web, it cannot be integrated into desktop, it cannot be integrated into another tool. So when you have certain challenges like that, right, even in that case, the ease of use becomes an important thing. So many companies stick to a particular software because it's easy to use. They also have that in mind. Capabilities, what can that tool do for us? What kind of capabilities? Can it scale? Can it process fast? Can it be deployed? Can it be implemented into any other tool? So the capabilities also plays an important factor. Efficiency, naturally, how good is the tool, the efficiency. I think the last point is quite important, legacy. Because I remember during my college days, let's say, I studied something called Fox Pro. Okay, Fox Pro, Fortran, and all those things. But now we won't see that much being used, right? But again, if you think of it, there are certain companies which still use Fox Pro. Okay, Fox Pro is because it has been a legacy. Let's say for past 25 years they have been using that tool. But now what happens in that thing is like it was like 25 years back, right? So there is a lot of advancement that has happened. So that tool will not have that capability. But the problem is now to move from that capability of what is happening already in the existing tool to a new capability is an investment that they need to do. If the company is ready to do that investment, then they will move it. But you know how much of efforts it is required, right? Because the old one is a set process. Okay, it's a set process. Everything has been tested, everything works fine, people are familiar with the process, so it becomes easy to continue. But if it is having challenges, like it is not able to scale up, it is that new data is coming, the data size is very big, and this tool is not able to support it, then the companies start thinking of moving towards new technology. Then legacy, right, plays a very big role. If they want to move or not is a big challenge. So if they move, they have to invest in the resources to do the transfer of it from old technology to new technology. Then they have to train their team members. Then there is a lot of testing that has to be done. If small thing goes wrong, then it can trigger a big process of problems, right? So there's a lot of things that need to be handled. Okay, that's why they continue with most of the old tools. Okay, so that's like the basis for any company to select their tool. Okay, like many companies now, but now many of the companies are adopting open source, so that's one good thing. An advantage of open source is they are used by many companies. It's not an internal tool, right? So when it is an internal tool, there is a challenge that it is very specific to a particular company. So you don't have a market for yourself, right? Because outside other companies may not be using that tool. But when it's an open source, there are many companies adopting it. So there is bigger scope for you to have a market for yourself. Okay, all right. So next, let's see, like the analytics process. I know this has been a lot of talking and all. It's like more of theory and giving you an idea, but this will set the base for you all. Tomorrow onwards, right? We'll be having a little bit of programming will start, so that should get you more on the hands-on side. But the whole idea of this first session is to get you a hang of how this side of work, it gets along. Like how do you do this process? Why do we do it and all? Okay, and one of the most important thing I think whenever you are getting into an analytics project is the process that is there in place. So the process that you see in front of you, right? This is general process that is followed in any project. First thing, first thing is the business understanding. Business understanding is basically, like I told you, you don't have to be an expert, but you need to understand the business. Otherwise what you implement may not make sense. So that is why you need to make sure that you understand the business. I have worked in so many domains. It's not that without the knowledge of that domain I have worked. Once I get in, I take a lot of trainings for that domain to understand that domain, right? Because the people who are working in that domain will talk in those terminologies. And when they are talking and explaining you with those terminologies, you need to be aware what he's trying to explain. That is why the business understanding is one of the important aspects. When you're working in a service sector, right? Like this service based companies, there you will have multiple clients, right? It's not like you're a product company or you're a manufacturing company where you're related to a particular domain, right? When you're working in a service based companies, you will have multiple clients. There'll be clients from aviation, HR, pharma, retail. There'll be many. So whenever you're moving into a particular project, you need to understand the domain. So business understanding is always an important aspect. Let's take, for example, insurance. Okay, I'll try to explain this whole thing with an insurance perspective. I mean, you want me particular domain to take, I can take that also, but I'm going with insurance. I can explain you if you have anything on another domain, I can explain you how it will go in that domain as well. So when you take up a particular domain, let's take insurance. So business understanding. First thing is I try to understand what is the problem statement. He comes with me, the business team. They say we are having a lot of fraudulent claims, but we are not able to detect it. I need to understand how we can detect this kind of problems of fraudulent claims. Okay, now this is the high level problem statement that I have got from the business team. So I need to understand now what is this claims, what is the claims process. I need to understand the terminologies. You need to understand the adjuster notes, the claim handlers. There are a lot of other terminologies which are there, right? Loss ratios, all the lot of things will be there of that domain. So you need to understand. Once you understand that, the business team, what they will do, they will give you a data, what they feel is relevant to their problem statement. So once you get the data, you need to understand the data. And this is something I keep telling to everyone. Understanding data is more important than jumping into the models. It's very fancy to build complex models and all those things, but understanding data is the major aspect of it, because models are nothing but they are just some equations. Whatever data you do, they will give you some output. But what data you're giving is important. So you need to make sure that you understand the data that you're giving. So data understanding is the second most important part. And if you notice here, there is a to and fro, right? So you take the data, you understand, you have some challenges or you have some questions, you go back to the business team. I talk to them, I understand what is the, let's say they come up with a term called adjuster notes. Okay, there is a term called adjuster notes. So now I don't know what is adjuster notes. I go back to the business team, I talk to them, I understand what it is, come back again, work with the data. Okay, and I do some basic data analysis, okay, on that. Next step is data preparation. This is like a raw data set. They have given you a dump. Whatever they have got, they have dumped it on you. But not all the data which is there in that is going to be helpful for you. Or you need to tweak the data, or you need to change the data. So you need to do some pre-processing. That is where you come into the data preparation phase. Okay, so here you prepare the data that you have got, the data, raw data dump that has been thrown at you. You take that and prepare it in a format which is neat, which is clean, which can be used for the next step, which is modeling. What is modeling? Modeling is nothing but it's an equation. Okay, mathematical equation. Think of you remember our school days equations, right? Y equal to mx plus c. What equation is this? Y equal to mx plus c. Linear. Okay, or it's a line, right? Equation of a line, correct? So that's a model. Okay, we call that as a model. It's an equation, we call it as a model. So like this, you will be creating many equations internally when you build models. Okay, y equal to mx plus c is like a very basic form. It's a very basic form of an equation. You can create more complicated versions of it. Mx square plus mx cube plus something like all these kind of equations, fancy equations you can create. So this part is called modeling. Okay, so you create complex mathematical models. So that is where you start doing the modeling. Modeling again is a to and fro process. To and fro process between what? The modeling and the data preparation. Sometimes you don't realize that you could have done something wrong in the data preparation, which your model may show you, saying that some value may come out which may be weird, which may look a little weird. Then you go back and check in your data why it is causing that. You realize that there is something wrong over there. Then you correct your data, and then again you do your modeling. So like this data preparation and modeling are basically a to and fro. Okay. Finally, when you're done with your modeling, you need to evaluate your model. What is evaluation? Basically, just imagine what you have done is in a closed environment. See, just think of your COVID vaccines, okay, that people are working on. Right now, all the phase 1, phase 2, phase 3 trials which happen, right? Phase 1 is, let's say, on animal, like some animals they tested, right? So that is within a smaller environment that they are doing, right? Phase 2, phase 3 is on a larger scale. They are doing it on a bigger population, and then a bigger population, human population they are doing, and then they give it to the whole population. So if you notice, first it is being done in a smaller environment to see how it is performing, right? That is what your evaluation is. You evaluate the model or the equation that you have built. How is it performing inside an environment? When I say an environment, it's like, is the equation giving you correct answer or not? That is what you're evaluating. Okay, so you do the evaluation, and this evaluation again can lead you to the starting step. It can happen. You realize when you're evaluating, the business team looks at it and says, no, this is not telling the actual scenario. What happens? You again go back to the business understanding, and this whole process can happen. Okay, and I mean, although it looks like this here, your this whole process can happen at any step also. It can happen. You cannot tell like it will start like this only. So evaluation can also lead to going back to the starting step, because something could be fundamentally wrong. Like for example, your equation is doing it well, but business wise it doesn't make sense, right? In real life it doesn't make sense. So then what you do, you go back and again speak to the business team to understand why it is happening, what could be the scenarios. Then again this whole process could happen. Once you are satisfied with this whole step of evaluation, whole team is satisfied, then you do a deployment. Deployment is like giving it to the final customer, so he will start using it in real time. Okay, so this is like a whole cycle of process that happens when you're going through a project. And these steps could happen multiple times, any of these steps, and there could be additional steps also, but these are some of the major steps that you go through. And frankly to tell you, I would say like this phase, right, of here to here, the business understanding till data preparation, will consume your 80% of your time. Vineet, you're asking, is there any case study you can share it to understand? Yeah, sure, sure. We have one we'll be discussing. Okay. So this part, right, as I was telling, it takes 80% of your time. 80%. Just imagine if your project is for 3 months, I would say almost like 2 months of your time will go in data preparation. And that is one of the most challenging and time consuming work. Modeling is far easy because there are already things available. You just have to give the data to it. That's it. This part goes fast. This part is a time consuming. So it's always better to focus on getting that part done.